Today's lesson is on circumference and covers pages 199 and 200. Before we start looking at the questions, we're going to learn about some vocabulary. So as you remember, the distance around a polygon, which is just a shape, is called the perimeter. Now, for a circle, we have a special word for perimeter, and the perimeter of a circle is called the circumference. So this is the distance around a circle. In question 1, we're going to be looking at regular polygons. So a polygon is considered regular if all of its sides and all of its angles are equal. So the table gives us the width and side lengths of different regular polygons. We have two jobs. Our first job is to find the perimeter of each regular polygon and then to find the ratio of the perimeter to the width. So we can fill this in together. If we have a width of 1 centimeter for this square, it has 4 equal sides. So the width is the distance across. The side length is 1, so each side is 1 centimeter. The perimeter would be 1 centimeter, which is the side length, times the number of sides 4 equals 4 centimeters. When we write our ratio here, we're going to write the number for our perimeter, which is 4. Then we'll put our colon and put the number for our width, which is 1 centimeter. If we look at our next one, we have a width of 2 and we have a side length of 2. We're still imagining that this is a square. So if we fill this in, we would see that the perimeter would be 2 centimeters times 4 sides equals 8 centimeters. So our perimeter would be 8 centimeters and our ratio would be, our perimeter is 8 and our width is 2, which is also the same thing as 4 to 1 if we were to take it to simplest terms. Now, I'm going to let you do the last one on your own, but I'm going to look at the hexagon and do one question for hexagon and one for octagon, and you can fill in the rest of the boxes on your own. So the hexagons have 6 equal sides. So if they have a width of 2 centimeters, that means the distance from one point to the other, a side length of 1, so that's the actual edges. The perimeter would be 1 centimeter times 6 sides, which equals 6 centimeters, and the ratio would be 6 centimeters to a width of 2 centimeters, which is the same thing as 3 to 1. Okay? Now, if we look at their octagon, we have a width, maybe we'll do the second hexagon. So we have a width of 4 and a side length of 2. So our perimeter would be 2 centimeter side length times 6 sides equals 12 centimeters. So our perimeter is 12 centimeters and our ratio is 12 to 4, which is the same thing. If we divide them both by 4, we get 3 to 1. Now we'll do 2 of the ones for octagons and I'll let you fill in the third column. We've had a width of 8, so that's all the way across, a side length of 3. Our perimeter is, well, what's our side length? 3 centimeters times 8 is the number of sides equals 24 centimeters. Therefore, our ratio is 24 to 8, which if we divide them both by 3, or both by 8, you go 8, 16, 24 is 3 to 1. Now we can look at the next one and do the same thing. So we have our width of 4, our side length of 1.5. So to find our perimeter, we need to think, okay, our side length is 1.5 times 8, which gives us, well, 1.5, 3, 4.5, 6. So that's 6, so it's going to give us about 12. Now, 12 centimeters, our ratio would be 12 to 4, which if we divided them both by 4 gives us 3 to 1. So when we bring down our work to question C, they're going to ask us, what do you notice about the ratios P, W in each row? And if everything has gone correctly, you might notice that they all simplify to the same thing. You'll have to figure out the last row to see if that's true, but do they always equal the same thing in each row? Then, for a square, the ratio is 4 to 1, so the perimeter of a square is 4 times larger than its width. For a hexagon, the ratio is, perimeter is usually 3 to 1. So you would say how many times bigger it is and do the same thing for the octagon. In the midst of this lesson, we're going to have an investigation. So these are questions where we're doing some searching to figure out a lesson they're trying to teach us. So we're investigating what the ratio of the circumference of a circle is to its diameter or width. So to begin with, we're measuring the diameter or width of the circles and then estimating the circumference of the circle by calculating the perimeter of the regular octagon. So the first thing you do is measure across. So they're showing us that they measured, and the distance across the circle from one edge to the other was 22 millimeters. So that was going from one edge straight to the other. Then for the side of the octagon, they just measured one side length, and they said that was about 8 millimeters. Finally, they figured out the perimeter. So if we have 8 millimeters and there's 8 sides, altogether that's 64. That's where they got their 64 from. When they get to circumference, they're not changing the number, but they're acknowledging it's not exactly 64. So you need to include the word about. So to go from the perimeter of the octagon to the circumference, you don't change the number, but you do add the word about. Okay? Then for part B, we need to determine the ratio of the circumference to the diameter of each circle above. Then we need to divide the circumference by the diameter to write each ratio. So I'm going to show this to you. We're going from C to D. So if we look at our first question here, our circumference was 64 and our diameter was 22. If you use a calculator, and we need to divide both of these by 22. So if you look at 64 divided by 22 is about 2.9, and 22 divided by 22 is 1. You'll need to do this for all of them. And then the ratio of circumference to the diameter of the circle is about. So figure out what number is this about each time when we bring it down to the unit, okay? For question C, they're going to give you the diameters and circumference of some circles. Find the ratio of circumference to diameter for each circle and write each ratio in the form unknown to 1. So we're making it all a unit ratio. What do you notice? We can't fill this part out until we complete this part. So what they've done is they've gone, okay, 315.7 divided by 5 gives us about 3.14 to 1 when you divide both of these numbers by 5. Now, if we have 31.4, we're going to divide both of these numbers by 10 to get our unit. So 1.4 divided by 10 is 3.14, and 10 divided by 10 is 1. Oh, I can see already that these are the same number. As you calculate the rest of these, see if you notice, are they all the same number? If they are, this is something you can write in the box. What they're trying to get you to learn is the ratio of circumference to diameter is the same for all circles. This number has an infinite number of digits after its decimal point. So this number for the 3.14, it is more than 3.14. Mathematicians use the Greek letter pi, which is pronounced pi, to identify it. So pi is about 3.14. The digits go on infinitely. We just worry about 3.14. So the ratio of circumference to diameter is pi to 1. So circumference is pi times larger than the diameter. The formulas we can use are pi times diameter, which is the same thing as pi times 2 times the radius, because remember the diameter is 2 radii, which is the same thing as 2 pi times the radius, which is where we get 2 pi r. And this is the formula you will most likely memorize for all of high school. Our final question will be number 2. They're going to tell you either the diameter or the radius, and they're going to ask you to figure out what the circumference is approximately using 3.14 for pi. So if we were to look at this, if the diameter is 7, we know that circumference, I'm just going to write that with a C, is like pi times the diameter. So that means my circumference is going to be like 3.14 times 7 meters. And then I can calculate, and I will let you use a calculator for this. 3.14 times 7 is 21.98, and we'll keep our unit there, so it should be meters. So this will be our answer for, say, part A. They might also tell you a radius. If they say that your radius is 3 centimeters, then you need to know, okay, my circumference is pi times 2 radiuses, right? So then I need 3.14 times 2 times 3, which is my radius. So if I put that into my calculator, 3.14 times 6, I get 18.84 centimeters. So that's going to be about my circumference if my radius is 3.